All right, hello, welcome. I'm your host, Ryan Hines. I'm the Communications Manager at BIOMIN, and I want to thank you for joining us today for the next issue in our BIOMIN Antibiotic Reduction Expert Series. The topic that we're addressing is non-antibiotic strategies for control of necrotic enteritis. I'm joined today by our featured expert speaker, Dr. Lisa Bielke, Assistant Professor of Animal Sciences at The Ohio State University. Dr. Bielke, thank you for joining us today.
Thank you for having me. I want to say I just have to give a little shout out to my nephew that made this nice piece of artwork on the screen you see behind me, on the wall behind me. Last night we had a birthday party for his mother online, and I told him that this was going to be internationally displayed, and it kind of embarrassed him a little bit, but he's excited about it.
It is a chicken, if I'm not mistaken.
It is, yeah. Yeah, it's,
excellent.
I guess, a rooster giving a brief tail on it.
Okay.
It was a birthday present a few weeks ago.
Great to see that. Great to see a young budding artist in work.
Yep.
Dr. Bielke, why don't you tell us a little bit about yourself and your work?
Sure. I study poultry health, primarily gut health. I'm at Ohio State University, and necrotic enteritis has been a big disease that we study. It's a global problem, and we're obviously, since I'm presenting here today, working on non-antibiotic ways to control it. I've lived in Ohio for going on 5 years now. I've slowly moved my way north across the United States. If I go any further north, I'll be in Canada. So I think I've gone as far as I'm going to go probably. I've worked in the gut health area for pretty much the entirety of my career. It started with salmonella, but we've migrated on to necrotic enteritis. And I find it really interesting, especially the Coccidia interactions that go with it. So I also study Eimeria quite a bit, and hopefully one day we find a really good way to control it.
Absolutely, and we're going to be looking to the insights that you brought with us today to see what the current state is and what tools that we can use until there is further advancement in the field. But before I ask you to start your presentation and walk us through your slide deck, I want to speak to our live listeners right now. Just as a reminder, this is an interactive session, so that means two things in particular for today. As a participant, you can enter your questions for Dr. Bielke in the chat function, and we will try to answer as many of these questions as we can later on at the end in our Q&A portion of today's broadcast. Second, we're also going to be able to ask you a couple of audience poll questions where we'll feature a single question and ask you to choose an answer, and we'll be able to share those results out in order to continue the discussion on today's topic. All right. So, Dr. Bielke, please take us into your presentation. We look forward to hearing more about this very clear, very prevalent problem in the commercial poultry industry, and looking forward to speaking to you again a bit later when we talk to our audience, and then later in the Q&A.
Okay, thank you. Let's see if we can, there it goes. Okay, so again, just to go over the title again, these are going to be focusing on non-antibiotic strategies, specifically for control of necrotic enteritis in poultry, but mostly chicken. So I wanted to start out going over the importance of gut health in raising animals and how we define health. Typically, what I really like to teach my students at the university is that health is more about gut homeostasis, that, you know, we really need to be focusing on maintaining homeostasis, because whenever we leave that, that's when we start to get into a disease state. And I don't know that you can go beyond homeostasis. You just want good, the best that you can reach, where the bacteria and the food items within the gut or the digesta and the animal are working in a eubiotic relationship, where there's some synergy between the host and what's in the gut, and everything's protected, and we don't have leaky gut type of situation, and there's not a lot of toxins. There's increased diversity. Cell turnover is really good, and we've got good nutrient absorption, which is our primary function of the gut. And a big thing to always remember is that as this eubiotic relationship breaks down and we start to enter a dysbiotic relationship, that's when we get into a state that the animals are at increased risk of getting an opportunistic disease. And necrotic enteritis is certainly an opportunistic disease in that Clostridium is always present within the gut, and something has to happen to make the conditions favorable for Clostridium to overgrow. And I'll get into a little bit of necrotic enteritis specifically here in a few minutes or in a second to describe the disease to you, so that we're all going in with a good understanding. But I wanted to first point out a recent poll, and now this is in the United States. I haven't seen a global poll or one for other countries, obviously being based in the United States. This is what I have the most access to, but it's my understanding that this is pretty much the way it is globally. Necrotic enteritis is actually the second highest disease of concern. But what's important to note here is that coccidiosis is the #1 disease, and actually coccidiosis and Eimeria contribute to the development of necrotic enteritis in a lot of conditions. It's almost always present, sometimes subclinical, but it's there. And when we start looking at what contributes to the development of necrotic enteritis, in addition to Eimeria, there's a lot going on in the gut that can favor it. And it doesn't have to be all of these things, it can be some. So I've actually used salmonella sometimes as a predisposing factor for induction of the disease, but really there's a lot of diseases that have been associated with it. And also over here on the diet components, if you've got low quality diets that have high non-starch polysaccharides or mycotoxins or some type of other contamination, and even the type of protein that's present, we know that fish meal can definitely contribute to it. A lot of researchers use fish meal as a way to induce necrotic enteritis. These things can also contribute to necrotic enteritis, and or the overgrowth of Clostridium within the gut. So diet's definitely also a major concern. And then the role that Eimeria plays is that it induces inflammation and epithelial damage in the gut. And those can be induced by these other things that I've mentioned. So it's really quite a complicated disease. And I think the best way to control it is to focus on just maintaining gut health and reaching that homeostasis state, so that the Clostridium doesn't overgrow and begin producing toxins that cause damage. So to go a little bit into necrotic enteritis, just to make sure that everyone here on the webinar understands what I'm talking about, specifically the disease, so that you can understand how to control it a little bit better. Clostridium Perfringens is the causative agent. Now, it is a spore former, so it can be difficult to eradicate from your barns once it's there. But also, it's a normal bacteria within the gut of chickens. It's there. It can be found in the ceca mostly. We get necrotic enteritis when it moves up out of the ceca and into the small intestine, and it begins growing a lot. So generally speaking, we can see necrotic enteritis in young birds, but it tends to happen in this 3rd into the 4th week of life. This day 16 to about 28 or so is when we really see it, and that's associated with Eimeria vaccinations and the cycling of oocysts. So anyone that's vaccinating for Eimeria should be aware of it. But other things can be going on. I think this is also just this state where the gut's reaching sort of its anaerobic state, and bacteria are really becoming more mature within the gut. So the type of Clostridium that causes disease in poultry is toxinotype A. The others are not really associated with disease in poultry. So not all Clostridium Perfringens in terms of disease for poultry is bad. It has a lot of toxins. To date, up to 16 have been identified, and it seems like we're getting more and more. Some are plasma associated, and that's where they come from, like that B toxin, but some of them are within the genome permanently, and alpha toxin is the big one. And so That's the big identifier. That's what all toxinotype A's have, and that's actually what we use whenever we're trying to quantify Clostridium within the gut. So the very effective nutrient scavenger. All of these toxins that it produces are associated with acquiring nutrients, and that's basically what pathogens are good at, is acquiring their nutrients that they need to grow somehow and take over. And it also has Clostridium also has some systems for, it's a type of quorum sensing mechanism that it can sense what's going on in its environment really well. And this has been identified even in Staphylococcus and other pathogens across the board for all animals, including humans. So, so that's just one of these mechanisms that it can use to really overgrow. And so once it senses that, there's a favorable condition in the small intestine, it can start to migrate up there and go after those nutrients that it wants. And so that's where controlling the whole gut becomes a priority whenever we're trying to control these diseases. So when we're looking at necrotic enteritis field, what are we going to see? Well, first off, it's a very short-lived disease in terms of a singular animal. Probably only about 48 hours is what you're looking at. Whenever we're doing inducing it in the lab and we want to have animals, all synchronized at once, we do about 48 to 72 hours. It's whenever we're going to see it, and then after that, most everything is recovered or not, and it's over. So it's very, very short. Now you may see it rolling through a flock and it looks like it's a long disease, but really on the individual bird, it's quite short. And so I put some pictures in here of what you'll see the birds doing. These birds, they have a fever and they're not feeling well, and they get pasty vents, and this huddling and ruffled feathers is associated with their fever. If you open up the guts, I think I've got it. Yeah, here on another slide. They're going to be a little bit gassy and they're really friable. They fall apart easily, and we have this this lesion scoring system. I think some other labs and veterinarians like to use a 6-point scoring system, but I find the 4-point works well because when we get too many scores to give, it starts getting kind of fuzzy. But at score level 1, this would be really just a subclinical. You're going to notice the birds are just not doing very well. They may be huddling a little bit and see some pasty vents, but it's really subclinical. And then when we start getting up into the 2 through 4 range, you're probably going to start seeing some mortality in the birds. And you're going to really want to be opening them up, and you'll see these changes. And it can be sometimes difficult to distinguish between necrotic enteritis and Eimeria, especially maxima, that affects the midgut. But there's really this necrotic look to it, and if you get into it enough times, you'll start to even recognize the smell of it. So it definitely is disruptive in the gut, and these birds they're not doing well, and it's going to affect your flocks. So really quick to go over how these vaccine complications affect it. So what I mentioned earlier is that the vaccinations actually really disrupt the gut. And so in order to get protection against Eimeria, they have to have the disease at least at a low level. And during the first cycle, in the first week, there's not really enough damage for Clostridium to take over and start causing disease. But as the oocysts that are in the feces, which also means oocysts and Eimeria within the gut, starts to increase, that's when Clostridium Perfringens starts to get those really, in terms of for Clostridium, really good conditions that it favors, and it can start to grow. So this is really the period when you're going to see it if you're vaccinating for Eimeria. And some of the precocious strains, they can eliminate the risk. They cycle at a little bit lower numbers within the animal, and so they can decrease the risk for Eimeria, for necrotic enteritis, but they don't completely eliminate it. But it's this cycling through the flock that you're going to see it. And once your birds have developed immunity, the risk for necrotic enteritis really shoots down. So what are we talking about in terms of how it affects the overall flock, and really kind of into the economics of it a little bit. We published a study last year in which we induced necrotic enteritis in birds through a couple of different methods, and we followed them out all the way. We took them past 56 days, well, up to 56 days of age. And that was mostly to see, do they ever actually recover from it? And does that growth curve come back and will they reach it? And the answer is 56 days of age, as you can see here, the answer is no. But if you look at the market weight, inducing necrotic enteritis actually delayed it here. So to explain the graph a little bit, we were just following body weight, obviously. But we did here we've got two different methods that we used. One was NetB1 strain, and this was just Clostridium Perfringens administered to the birds with no other predisposing factors. And it was really a subclinical in terms of lesion scores. There was not, there were some ones in there, but there wasn't a whole lot. But we did notice that there was a decrease in body weight gain. And so even that subclinical necrotic enteritis extended market age. Since this is a linear curve, it's really hard to do the mathematical models to get it. But we can see here just at market weight, it was extended. And then we did another, it was a different, different Clostridium, not this one. And we combined it with an Imurium maxima. And they had a little bit higher in terms of lesion scores. And we saw the changes here, obviously, since it's always below the gray line, a greater change in body weight gain, and it extended it even further. And also, in addition to even just extending the time it took the birds to get to market age, we saw an increase in variation in those body weights. And that becomes important when you're trying to meet a specific bird size for markets like the restaurant markets and the cut-up markets, where there's a very specific size range that needs to go in there. So not only did we extend the time that the birds need to reach the size, we also increase that variability, which decreases the number of birds that you've got to meet your specific customer requirements. And so now we've explained the disease and why we care about it. I'll go over some of the strategies that are either under development or that we currently have for controlling necrotic enteritis. And all of these focus on the prevention side. I think really the only thing we have for treating them is antibiotics. And if you're trying to go without antibiotics, then you've got to really focus on prevention strategies. And that's going to be a theme throughout the rest of the presentation. And so vaccines, there aren't any that I know of right now, but there are a lot of people working on them. So last December, I went to an alternatives to antibiotics symposium or conference and gave a talk about vaccines under development. And this conference was not designed to focus on Clostridium Perfringens and necrotic enteritis. There are a lot of topics across the board over the week, but it turned out in the vaccines section, 3 of the 5 presentations were all about necrotic enteritis. And actually one other person that gave a talk there also works on vaccines for necrotic enteritis. That's just not what he was talking about that week. So the big thing that we came away from after our roundtable discussions at this conference was that Clostridium is an abundant enzyme producer, and we really need to focus on finding ways to vaccinate against all of the ways that it can cause disease. We know that if we can vaccinate animals against the native alpha toxin, that we can decrease necrotic enteritis. But it's really difficult to vaccinate against that toxin because we need to neutralize it before we administer it to the animal somehow. And so that it gets really complicated when you get into the nuances of it. But even that's not a perfect system. But really what it comes down to is we don't have a vaccine yet, we're working on it, and it's complicated. So I would not be counting on a vaccine to be coming out in the next year or so. Though I know quite a few people, including myself, are working on strategies to make this happen. And I think it's going to come down to some subunit and recombinant vaccines, which in themselves just get complicated too. So the next thing is antibiotics. So we know that if we've got an antibiotic that Clostridium Perfringens is susceptible to and the animals break with it, we can administer it and take care of the flock and have it under control. Historically, subtherapeutic antibiotics have been a good strategy for controlling it, but for a variety of reasons, we're not not doing that anymore. Some of it's consumer driven, some of it's actual scientifically driven. So they're either not allowed or heavily restricted in large parts of the world. And so really, I think if you have a specific necrotic enteritis problem or a heavy necrotic enteritis problem, and you're not trying to do an antibiotic-free program, then you can go ahead and use subtherapeutic antibiotics to control it. We know that works. If you know the Clostridium that's on your farm is susceptible to that antibiotic, then it can be used. The other thing that we also need to remember when we're talking about antibiotics is that ionophores are actually classified as antibiotics. And so that decreases some of the control mechanisms for a predisposing factor to Eimeria and Coccidia. So a lot of people that, or a lot of producers that are trying to do these antibiotic-free programs are also limited in their methods of controlling Eimeria within their flocks. And especially for those that use a bio-shuttle program.
Yeah, pardon me.
So
we just want to jump in.
Uh-huh.
As we're looking here at these options, and of course the main presentation focuses on the non-antibiotic versions. Let's turn to our audience for a moment, allow you to refresh yourself and see what their level of familiarity with these other options as you then go into more detail with them. So this is our first audience poll question. I would ask you to choose the one best answer that fits your situation. Do you have experience with non-antibiotic strategies to control necrotic enteritis? Yes, I have success with non-antibiotic necrotic enteritis control. Yes, but I have limited success in looking for ways to improve. No, I do not have experience with these non-antibiotic methods, or not sure. Please go ahead and choose that best answer that fits your situation. And as these results come in, we're going to actually go ahead and display them back so that everyone can see and give Dr. Bielke also a chance to comment on this as well. So with roughly half of everyone voted, I want to thank you for that input. We are going to close the poll now. And as promised, I'm going to put up the results for us to have a look at. So here's what you told us. Yes, we have 19% of those listening live right now do have success in non-antibiotic necrotic control, which is great. There's a larger proportion, nearly 40%, that have some limited success and are looking for ways to improve. We very much hope that you'll have some ideas from the back of that from today's discussion. Roughly a third, or 34%, do not yet have experience with the non-antibiotic forms, and 8% are not sure. So that gives us a gauge, Dr. Bielke, of where our audience is in terms of actually implementing some of these strategies on their operation.
Yeah, so I really hope that the people that have not had any experience with it yet learned something today. And I think we'll have an opportunity later to gauge what types people have used or are interested in using. So
absolutely.
I'm looking forward to that. Yeah.
We'll be back shortly with our second poll question. All right. So please continue on. And
yeah. Okay, so to go through some of these options, I'm sure that since quite a few of you have used non-antibiotic methods before, that these are going to look quite familiar to you, that hopefully you learned something from them today. So one of the big classes of non-antibiotic control methods is the probiotics, and I class them together with prebiotics, which makes a synbiotic quite a bit, because prebiotics help make sure that the nutrients that our probiotics need are present. So they work in a relationship that goes between the host and the microbiota and the probiotics that are there. And prebiotics specifically only act on the probiotic. And the three of these all work together to create this sort of a holistic control within the gut. the probiotics and prebiotics have been documented to have quite a few mechanisms of action. I'm not going to go into all of these today. We would need all day to go through them all, but some of these are documented specifically in poultry. The immune system modulation and enzyme production, and we're going to go into organic acids here in a little while, and this colonization resistance, and all of these different things work together to improve the health of the gut, and sometimes to actually act specifically against the pathogens within the gut. There it goes. Okay, so we had a little bit of a delay there. So what is a prebiotic? Well, it's a substrate that is selectively utilized by microorganisms within the host to confer a health benefit. So by that definition, prebiotics cannot have a direct effect on the host. And I think that becomes important whenever you start looking for prebiotics, especially when there are claims that this prebiotic is an immune modulator. Well, maybe, but not directly in itself as a prebiotic. You really can't do that. It's got to be an immune modulator through a mechanism that with the probiotics or other bacteria within the gut. So prebiotics in our circle of mechanisms on how these synbiotics, prebiotics, and probiotics all work, the only one that prebiotics can do is this interaction with gut microbiota. That's the primary role within the gut, and anything else that comes from it is a secondary action. And I've got a few of these in here. I looked recently just to see how many of these different non-antibiotic control mechanisms have been published. So I use Google Scholar because that picks up some of the, or most of the non-indexed journals. So this is really a look at everything. And there's only about 1,000 results. And this was a recent search, so it's not like this was 2 years ago or so. This was actually within the last couple of months. So in terms of the internet, 1,000 results is not very many. So I think this is really an emerging area of research that definitely could be researched, investigated more, or developed more in as we find probiotics that work against necrotic enteritis and Clostridium Perfringens. We should look into prebiotics more to help make sure that those probiotics have what they need in the gut to do their thing and have their mechanism of action. So just to go over this and make sure I've really emphasized this on the prebiotics, is they provide nutrition to the microbiota. So this is normally a non-digestible fiber of some sort that the host would not necessarily be able to digest. And so the bacteria break that down, and then the bacteria will have an effect on the host, and that reduces our disease susceptibility. And so these effects that the microbiota can make through the prebiotic are quite broad. Immune modulation is definitely well documented, reduced inflammation, these volatile fatty acid production, and we'll get some explanation on how these work with the organic acids in a little bit, and then this direct action on the host. But again, it's not the prebiotics doing these, the prebiotic is used by the microbiota for the host to modulate these effects. So whenever we're using prebiotics, what do we want to ask? We'll start off with, well, how does it affect the microbiota? If you're considering a prebiotic, you're going to want to look for something that has a known mechanism of action. What types of bacteria does it affect? Which ones can utilize it? Are we doing the bifidobacteria and the lactic acid bacteria that really work well as probiotics, and the bacillus type species and whatnot? So is this prebiotic documented as something that really affects the probiotic that I need, and the type of bacteria that I need in the gut to prevent Clostridium Perfringens? And then I always stress as a scientist to look for published research, and especially peer-reviewed published research, to make sure that this is actually documented in a way that was methodically tested and checked to make sure it does what you do, and that you're not just getting a powder that, you know, mimics some other prebiotic, but it's never really been tested. Like, look specifically for publication on the product that you're considering. And then remember that if you want your prebiotic to have its best effect, consider putting in a probiotic that contains the bacteria that the prebiotic affects. And this really will help make sure that the product's doing what it's supposed to do and it's reaching its full potential in the gut. So with that, we'll go right into the probiotics, because that's what the prebiotics are affecting, and they're the way to really make sure it helps in the gut. So probiotics actually work on everything within our circle of gut health here. They can do all of these things. And colonization resistance, I think, is one of the important ones, but they do a lot. Improving barrier function. In terms of the necrotic enteritis, is not as important, because necrotic enteritis happens within the gut, but by improving barrier function, they can improve overall health. And inflammation is really a systemic problem. So if you can prevent inflammation elsewhere, you're really kind of decreasing it within the gut too. And interacting with other gut microbiota can be an important thing in terms of how they not only affect pathogens that are there, but either promote other beneficial bacteria, like our segmented filamentous bacteria that seem quite important these days, or other bacteria that can help break down the digestive and the feeds to make it absorbable. So, so probiotics are really the things that go all the way through our circle here. And so when we start talking about the mechanisms of action, the list can be quite long. It can get complicated, but I really like to focus on the four biggies. Number one being competition for nutrients, because pathogens need nutrients to grow. So we can select for probiotics that specifically compete for nutrients, and so they'll make them less available to the pathogens. And they also, whenever we're talking sort of about the competitive exclusion type of thing, they can block adhesion sites within the gut. And so this one's, I would say, it's with cellular turnover, it's kind of hard to comprehend how these adhesion sites are so important, but in reality, I guess there's a limited number of adhesion sites at any one time. So if you've got probiotic good bacteria that are there on that mucosal surface, and it's going to kind of crowd them out. But you got to remember that there's also cellular turnover. So that system gets a little bit complicated. But obviously, if there's only so much space, the more the good bacteria that are there, the less opportunity there is for the bad bacteria to get in. And there have been some studies that have shown that there are actually beneficial bacteria that get in here and attach. And whenever they're in there, they can have that direct antagonism effect here, where they produce bactericins and other things that the pathogens cannot survive. And the bactericins really are an antibiotic. They're just produced directly in the gut. And so, you can see on these agar plates here where a probiotic was put in the middle and a pathogen was overlaid, and they make this zone of inhibition that looks a lot like an antibiogram. And then the immune stimulation, I just put this this fluorescent image here. What it really shows is that, and this was in germ-free mice, but these mice were infected with a probiotic, and they actually did not produce IgA until they had been infected with the probiotic. And the germ-free mice that were never received that probiotic, their fluorescence in terms of IgA here, the bright green there, was actually quite a lot lower. So we know that bacteria interact with the immune system, and you want to make sure that immune system is being activated in the right way to stimulate a healthy gut and to help prevent disease. So like I said, there's quite a few mechanisms of action for probiotics. The International Association for Probiotics actually published a paper in the last few years that went over all these different mechanisms of action and classified them into, what are you most likely going to see within a probiotic, and what is harder to either define or to prove. And so in terms of when we're talking about poultry and controlling diseases, I bolded some of these here for you. So we can see direct antagonism quite a bit. I just showed you that's something we can test for. immunological effects, I think, are not rare in themselves. It's just hard to prove that the probiotic itself made that immunological effect. I've actually been working on that with some microbiome and proteomics work, and it is quite difficult. I can attest to that. And we definitely believe that's what we're seeing. It's just that proving that the probiotic itself was the effect is difficult. And so that's why it's classified as rare, is that the actual proof is difficult. But widespread, I think some of these, they're legit, they're real mechanisms of action, and they're easy to doc. So we see them quite a bit. These production of short-chain fatty acids and organic acids or volatile fatty acids is really easy to show colonization resistance. I mean, you can go back to the 70s with the Nurmi and Rantala papers and see that. So we've been proving that for a long time. And that goes along with the competitive exclusion. And then normalizing a disrupted microbiota. Those are all well proven and easy to see and document, and we can find plenty of publications on them. Whenever it comes to selecting our probiotics, what do we need to be thinking about here? Well, we always need to ask, is that probiotic appropriate for my problem? And that's the same thing that you would ask with anything that you were trying to treat for a problem, even with an antibiotic. Clostridium Perfringens is a gram-positive bacteria, so you wouldn't want to go grab any old antibiotic off the shelf, especially one that works only against gram-negative bacteria. So you always want to be asking, does this probiotic do what I need it to do? And can it be delivered to the gut? So especially if it's a non-spore-forming probiotic, you'll want to be looking for some sort of protection or way that it's getting delivered to the gut. It needs to get past the upper gut where there's plenty of enzymes and low pH and mechanisms there specifically designed to kill bacteria. I mean, well, also for digestion, but that low pH and a lot of those enzymes actually are a protective mechanism from keeping pathogens from getting into the gut. And again, I go back to looking for these mechanisms of actions and looking for data that are specific for the probiotic. And then where in my production chain is it going to be most effective? This is something that's vertically integrated and I need to be controlling it in the breeders. Is it something that maybe I should put in the hatchery that's coming about as a way to administer probiotics or very early in the hatchery, or should I just be putting it in my feed? So are they effective? Well, if you ask the literature, of course, prebiotics and probiotics are effective. Nobody's going to publish negative data. So I mean, I've seen probiotics and prebiotics that don't work against necrotic enteritis, but they work against other things. So again, that goes back to making sure that you've got a product that's going to work specifically against your problem. So you just look into the literature, ask the internet, find out what's going on there. Information is not hard to find these days. And also be looking for this mechanism of action. Is it something that's going to actually slow down or prevent this pathogenic cycle within Clostridium? And usually that comes down to nutrient utilization of Clostridium, but just go back to the literature and look for your data that shows that it is effective. I think they very well can be. I've seen plenty of them work. So I'm not sure why I have this Synbiotic slide in here. I've been talking about it quite a bit. Maybe this is just supposed to be a reminder to everyone that your Synbiotic is going to be a combination of your nutrients for bacteria and your probiotics, and you put them together, and then you complete this entire circle of prevention of disease. So we're going to move on to some of the other mechanisms. These are not going to be as in-depth. So immune stimulators, they really control this inflammatory response that gets unbalanced and affects the health in the gut and can reach that increased risk of opportunistic disease. So they can either work with the bacteria or they can work with the host. But really all they're doing is, they're not really a stimulator, they're more of a controller, excuse me. So instead of calling them immune stimulators, I prefer to call them immune regulators. But these can be really hard to prove, but again, I'll go back to look for the proof. There are some out there that I think have some mechanisms of action that are shown, maybe not specifically in poultry, but there are things that can work in controlling the immune system. I can anecdotally at least attest to the value of a diet and your immune system being overstimulated through that diet. So again, they're going to be prophylactic things. They're really not something that you're going to see happen overnight. That it's going to take time because the immune system, outside of a few instances, really does not have that rapid acute response that you're going to be looking for controlling necrotic enteritis. That it's going to be more prophylactic, and you're going to be looking for long-term control and really keeping that inflammation that the Clostridium can take advantage of under control in the birds. And so it's just really a complex relationship. And if you're going to use an immune stimulator, you're just going to want to have it in the diet all the time. So necrotic enteritis, excuse me, I forgot how to breathe here for a minute. So organic acids, these are actually quite common. So you can see here a Google Scholar search brought up over 3,000 results, and that's specifically for necrotic enteritis. So they've been around for a long time in controlling a lot of other diseases also. I was just focusing on necrotic enteritis here. And so the most common organic acids are the short chain fatty acids, and what you see a lot in the poultry industry is this acetic, formic, butyric lactic acids, propionic acids. Those are the ones that we see the most of. They do have a non-specific antimicrobial activity. So if you use organic acids, they're going to work against everything really, but that means they're also going to work against your Clostridium Perfringens. And there is some evidence out there that they can improve the proliferation within the intestinal cells. And that's, I think, mostly through them serving as an energy source for intestinal cells. And then the subsequent effects are the increased absorptive capacity. They can be used as precursors for some amino acids and lipids, and they can increase blood flow. So in addition to specifically working against bacteria, they do also help stimulate the gut. So let's go a little bit through how they work, and that'll help you understand what's going to be in the next slide about what you've got to do to make sure they're doing what you want them to do. So organic acids actually work best in the undissociated form. So whenever they get into a low pH within the gut, they'll reach this undissociated form. So whenever this hydrogen ion on our organic acid is dissociated, they're not going to be able to penetrate the cell wall of the bacterium. And so again, they get into this low pH condition and they'll become undissociated and they penetrate the cell wall. So once they're in there, the pH within the bacteria is actually high, right? They're going to be approaching a neutral pH, and so then it becomes dissociated. And this free hydrogen ion is actually not good. So the bacteria are going to pump this proton pump out, and as this hydrogen concentration or content increases, they're going to need to start pumping that out to maintain their conditions within the cell that they need. And so as they're pumping that out, they actually just essentially die of energy depletion in the end. So this is well defined, but then it also becomes important to recognize that this whole process depends on this undissociated form of the organic acids. And so where that becomes important is making sure that they actually get delivered to the appropriate site in the gut. So if they reach the ventriculus and they all become undissociated, they're not going to do what you want, because necrotic enteritis doesn't happen in the proventriculus. It happens in what I like to call the lower gut, the ceca and the ileum, the jejunum. So if the organic acid is becoming undissociated in the duodenum, you're not doing anything for your necrotic enteritis. So there are methods available that protect the acids through the upper gut. I shouldn't say we all, but many of us have taken medications before that are protected in a way to make sure that they get to where they need to go. That's either through extended release, specific pH or enzyme activity that they depend on to break down and release the component in the right place of the gut. So that's definitely something that's doable, and there are things out there that can make sure your organic acids get delivered to where they need to go. And so it's really important that you're doing that, and you're not just feeding it randomly to the birds, just for the sake of it. That you're going to want to look for the protection, and you're also going to want to look for evidence that the organic acid works against your target pathogen. I know we've seen plenty of organic acid data out there that shows it can work against necrotic enteritis, but I wouldn't go just throw anything in there. I would want to make sure that it does work against necrotic enteritis. So then I think we're getting to the end here. Essential oils is one of the final ones. This is emerging. If you had asked me about essential oils a few years ago, I would have probably laughed at you. There wasn't any evidence out there, but it's emerging. You can see there's only 877 results came out a few weeks ago. But I've been working with them a little bit and testing some, and I've actually seen some evidence for myself that they can work. I think one of the biggest things is controlling their stability and making sure that the ratios of essential oils are staying the way that they're supposed to be, and that they're stable and they've been stabilized so that they're doing what they need to do. So thymol, cinnamaldehyde, and carbachol are the three most common, but I've been seeing some anethol and citrus oils that are doing well. And actually, what I've seen also is that they have potential to control both Eimeria and Clostridium. So that's hitting as the two big important components when you're talking about infectious components for controlling necrotic enteritis. And so actually my lab has been working on some in vitro methods for testing these essential oils against Eimeria. And they've been having some successes. I'll say that not everything works, but there are some that do work. And we're actually working towards getting these in birds and going all the way through from the test tube to the animal to show it. But I think that they do have some ability to work against pathogens. They do have antiseptic qualities and antibacterial properties. And so it's going to be hard to find information out there right now because it's still emerging. But if you see some compelling evidence for some of these, I wouldn't dismiss them. I think that they do have potential, but also as we're working on it, I think I would consider combining them with other strategies until this is really worked out on how we're going to do it. But boy, I hope I'm publishing some promising results on these essential oils in the next few years. So to start winding down a little bit on our control strategies, I want to stress the Eimeria control. It's the most common method of inducing the disease. Whenever you scroll through the literature and you talk to scientists and researchers that are working on it, Eimeria, Eimeria, Eimeria. And now I understand that we have to either vaccinate for Eimeria or have some other way to control it, because sometimes it comes about by spontaneous generation. I mean, it doesn't, but we know sometimes it seems like it does. So keeping a good Eimeria control program is important. And if you're going to vaccinate, then you've got to really pay attention to preventing necrotic enteritis, because it happens. It is what it is. That's what we've got to do. And traditionally, we were using subtherapeutic antibiotics to control it in our Eimeria control programs also. But now that that's not as much of an option, then we've got to look at preventing it in other ways. So if in your program or in your production system, if you're seeing it, then if you're seeing necrotic enteritis, you're gonna want to look for what's causing it within your program. And so that's going to be your non-digested feed ingredients, low quality feeds that perhaps contain mycotoxins or non-starch polysaccharides, and look at what's going on in the gut that can cause this mucus production and leakage of plasma proteins that Clostridium can take advantage of. And always remember that control can happen through a variety of products, and you may need more than one product to really make it happen and hit all of the things that the Clostridium is taking advantage of within the gut. And so the process does start with identify your predisposing factors. Obviously, you want to go with management practices if you can, because those tend to not cost as much as adding something into the feed or water. But if your management practices aren't working, go ahead and put something in the feed and water, and just ask yourself, ask the salesman, ask your technical services people for evidence that it's actually going to work in your situation. And then really keep an overall holistic type of program that's based on prevention, because once the necrotic enteritis hits and your birds die, you can't get them back. But also we saw earlier that once they have a decrease in body weight gain, you're unlikely to get that body weight back on those birds before they need to go to market. So really put a plan together that's based on prevention. And so with that, I would like to thank you for taking the time to listen. And I believe that we are going to be able to take some questions.
That's absolutely right. Thank you for those remarks, Dr. Bielke. We do have plenty of questions that come in. We're going to take a few from the audience. And one of the things that you had touched on, let's see what our first one is, was relating to diet and the gut. And here our first question is there a relation between pellet size and particle size with the occurrence of necrotic enteritis? Is that something you've seen in research or?
So that's a little bit of an old topic. It might take me a second to talk through it and remember how this goes. So definitely we want to make sure that the pellet sizes are appropriate for making sure that the feed gets digested in the correct way, because Clostridium Perfringens can take advantage of anything that the bird's not taking up or breaking down as it goes through. What I'm not going to be able to recall immediately is what those sizes are. So I'm going to suggest that you go back and look through the literature specifically to find out what those are. But if you're having a necrotic enteritis problem and you're having a hard time getting it under control with things that you expect to get it under control, I would definitely look into that.
Okay, great. So definitely an encouragement to do your homework. Yeah.
Yeah.
Moving on to our second question. You discussed earlier among the options, I believe vaccines was at the top of your list for necrotic control, and you gave us an update on the current status of the technology there. And the question here is, do we have the same risk of using Cocci vaccines like the attenuated ones we use in the EU?
Okay, so I'm not sure I understand that. So,
for example, we've had recently in a past edition of this series, we saw that there were different types of vaccines that were used to Cocci vaccines that were used. Is the choice of the type of vaccine to control Cocci having any kind of effect on the occurrence or breakout of necrotic, as the two conditions are related?
Yeah. So some of those precocious vaccines, I think people are seeing less necrotic enteritis with it, but it doesn't completely eliminate the risk there, because it's still there, and just by the nature of how those vaccines work, they have to induce some coccidiosis to stimulate that immune response. There's no killed vaccine options right now for Inurius. So even the precocious ones still have a risk, albeit a decreased risk. It still also comes down to management, and I think we see a lot of times the farms that have poor management, they're just always going to be a risk no matter what you do for them. So you know, we all know, all of us that have experienced Imuria before and worked with it, that managing that cycling of those oocysts is what's really important for controlling the disease and its side effects.
Great. Now, you run us through several different options, different strategies, categories of commercial product that can be added to feed or water, added to poultry diets. So what's the best one? Which is the one that everyone needs to buy? Because we've got a lot of questions. Everyone just says, okay, those are all nice and good, but please make it life easy for me.
Well,
What do you
so
think?
I'm not in the business of endorsing any specific product. I like probiotics, but probably because that's what I've worked with for the last 20 years. I've seen them do a lot of good things for animals. Where my research right now in prevention of diseases and promoting health is heading towards is getting those probiotics into the birds early, just to set up not only the gut bacteria, but also the immune system. But then again, I just told you that I've been working with some essential oils lately, and I'm seeing that they also have a potential effect. And honestly, I'm giving you a non-answer because I could give you experiences that I've had with pretty much everything in the presentation today that have worked well. I've seen organic acids do really well too. So yeah, you get a non-answer on that one because I think there's potential for everything. And really, you just got to look for what's going to go in your system, because I can tell you that I'm high on probiotics as early as you can get them into the birds. But then if your hatchery is not set up to handle that very well, then you're going to have to look for something else. So it's really unique to your system.
Absolutely, that's quite a good non-answer, I must say. And closely related to that, and you've suggested now, I think a couple of times, that often the solution might be looking at combinations of these products, not simply one, but an essential oil and a probiotic, for example. Does that entail any risks? Anything that anyone should consider or watch out for? We have a specific question here. Would it be possible that the essential oils would actually kill a probiotic? And so you're adding a lot of cost to your system, but really it's counterproductive.
Mm-hmm. Yeah, absolutely. So, and that's going to be unique to every situation. So you're not going to find anything easily that says, well, thymol kills lactic acid bacteria, and you don't want to combine the two, because that's going to depend on the products too. Because your lactic acid bacteria may be protected in a way that not only protects it as it goes through the gut, but it also becomes not susceptible to the thymol. So if you're putting thymol in the feed, but your lactic acid bacteria are protected, they may actually both get there. So it gets to be an expensive proposition to do it, but unless you see any direct evidence that these products are going to counteract each other, I would consider at least giving it a try.
Absolutely. A good piece of advice there. We have a practical experience here that was shared regarding probiotics. We said you've had more familiarity, let's say. And here they're incorporating probiotics into the feed formulation, but still seeing cases of necrotic enteritis. So what could be the reasons why this is happening, why the probiotic isn't, solving the problem, so to speak?
Well, that would take somebody actually coming out to your feed mill and your farms to help you take a look at it. So, I mean, it can be a variety of things. So even antibiotics fail sometimes. And so I think that a lot of people hold these probiotics and other mechanisms or other products to the same standard as antibiotics. And that's because that's what we want, right? We had a great tool for a very long time. But the substitutes that we have or new products that we have that work against necrotic enteritis or any other disease, bacterial disease, they're not antibiotics. If they did what an antibiotic does, we would call them an antibiotic. So these, specifically we're talking about probiotics here, their mechanisms and what they do within a system can be quite specific, and they do fail, but oftentimes it's because you're not using the right probiotic for your production system. And so a lot of times I think that's going to come down to figuring out what your predisposing factors are and finding a probiotic that can help control those predisposing factors. And that's why I said I think you really need someone to come into your farms and really help you go through okay, what is it in my farms that's causing necrotic enteritis, and then look for a probiotic that can help with that problem.
Absolutely. And just a very small plug for BIOMIN. Their sales and expert technical teams are certainly available throughout the world to accommodate you and do some of that on-site work if you're looking for a appropriate product to fit your situation. Dr. Bielke, I want to thank you. We have come to the end of our time today. Thank you very much for sharing this presentation, this information, your experience. I think it will help those of our listeners who are looking to either start or to improve on their non-antibiotic necrotic enteritis program. We appreciate your time. I want to also thank all of our audience, live audience members for listening. As soon as we close this session, we would appreciate you take the 1 or 2 minutes to give us your feedback on what we could improve and what topics we may be able to address in these future seminars. And we are also doing a deep dive into the essential oils and phytogenic feed additives category in just 2 days. So for those of you who are available, please have a look for that. You may be interested in learning more with one of the BIOMIN experts on the topic. So on behalf of BIOMIN, I want to thank you all. Thank you, Dr. Bielke. Thank our audience. And we'll see you again next time for the next Antibiotic Reduction Expert Series webinar. Thank you.
Thank you, everyone.